In this video, we're going to talk about end behavior of rational functions. Now, end behavior of rational functions is different than polynomial functions. So pay close attention to when we talk about end behavior. We're going to go ahead and we're going to review a couple of things here. We're going to review vertical asymptote, horizontal asymptote, and holes. So the first thing that's probably the easiest to look at would be our horizontal asymptote. So our horizontal asymptote, we're just going to look at the ratio of our highest degree. So our ratio of our highest degree is 1 over 1. So the horizontal asymptote is where y equals 1. Now this is going to be very, very, very important for when we're talking about end behavior, because our horizontal asymptote is actually linked to end behavior, and I'll come back to this. So this here is linked. Okay, so if we know the horizontal asymptote, we will know the end behavior. Okay, so now let's talk about vertical asymptotes. So if you remember, in order to get the vertical asymptote, the one thing that we need to make sure that we do is that we need to make sure that we factor the denominator. In fact, we're going to go ahead and we're going to factor both of these, and I'm just going to write it out for you. I'm not going to go through all the steps because hopefully you know by now how to factor. So when I factor the numerator, those are the factors I get. When I factor the denominator, those are the factors that I get. So for the horizontal asymptote, we have to remember our denominator cannot equal 0, which means we're going to look at x minus 2 at 0 and x plus 1 at 0. So I know here that x cannot be 2 and x cannot be negative 1. Those are my vertical asymptotes. In fact, let's go ahead and in our sketch, let's go ahead and sketch in those values. So x at 2 is here. Remember, x equals is a vertical line because everywhere there x is 2. X is negative 1. Those are asymptotes. And then I have a horizontal asymptote at y equals 1. So right here. Okay, so those are my vertical and horizontal asymptote. Now I also need to check to see if I have a hole. And the way I will tell if I have a hole is if I can divide something from the numerator from something from the denominator. And I can see right here that there is in fact a hole, which means I made a mistake. This here is not a vertical asymptote. This here is actually a hole. So I probably graphed too soon. So this here is not a vertical asymptote. This here is in fact a hole. So I'm just going to write a little notation there, and I'm going to write hole. This here I'm going to write VA for vertical asymptote, and this here I'm going to write HA for horizontal asymptote. Okay, so this here is not a vertical asymptote, and technically I shouldn't really even be sketching it in. But I'm going to leave it there for the time being so that when I go to sketch in the graph, I'll have things in the right way. So I already have entered everything into my calculator. So when I go to graph it, hold on, let me make sure I'm graphing the right one. Yep, okay. I have 2 equations in my calculator. So we can see that this looks like this. So that means that this is going to be coming down like this. Put arrows on the end. And remember, I'm just sketching. And this comes like this. Okay. So for me to mark my hole, I'm going to put a hole here. There's a hole right there on that function. That's where the hole is. Okay. So you can see on my calculator I can't see it, but I can clearly see the vertical asymptote and the horizontal asymptote. Okay, and then the other thing that we may want to do if we wanted to be accurate is it looks like there is in fact a 0 at -3. So technically this probably should have crossed right here, but it's just a sketch. Okay, so let's talk about end behavior. So I'm going to go ahead and review because some students are still a little confused about the notation. So if I have x goes to -infinity, this means the same thing as left side. So where is the left side? The left side is here. So I'm looking right there at my left side. So where is the function going? Well, it looks like this function right here is getting really close to the line y equals 1. So that means that my function is approaching 1. Now remember I said our horizontal asymptote is linked to the end behavior. If you notice our horizontal asymptote is 1. So our end behavior is also 1. So let's go ahead and look at the right side. So the notation for right side is x goes to +infinity. Again, this means right side. Okay, so where's the right side? The right side is right here. So I'm going to write this as, this is my right side. So where is my function going? You can see this here is getting close to that line y equals 1. So y gets stuck at 1. So I write that my function, or my output, is going to 1. Because remember, my y is my output. So my horizontal asymptote is linked to my end behavior of rational functions. Okay, so let's go ahead and look at this particular function here. So this particular function, we can again just put this directly into our calculator. What I want you to notice is that when we talk about horizontal asymptote, we have to be careful, okay? But let's look at vertical asymptote first. So vertical asymptote, we're just going to go ahead and we're going to look at our denominator. I don't have to multiply anything out. So I know that if I were to say 2x plus 3 equals 0, I get x, when I do the algebra, is -3/2. And then if I have x minus 1 equals 0, I have x at 1. So these are both vertical asymptotes right here. These are my vertical asymptotes. So I just want you to note that they're not always integer values. So I'll try to be a little bit more careful with my lineage here, my lines that I put on here. So -3/2. So -3/2 is like -1.5. So that would be about here. And x is 1 is here. So I don't have any holes because there's nothing I can divide out in the top or the bottom. So as far as holes go, there are none. So this graph is going to look a little bit different than the other graph that we previously did. Okay, so how do I figure out what my horizontal asymptote is? Well, to figure out the horizontal asymptote, I need to look at the ratio of exponents from the top to the bottom to see if they're the same. If we notice here, the reason I took the coefficient was because this is squared and this is squared. They're the same exponent, so I'm just going to do the coefficient. This one is not so. So if I were to multiply out my denominator, I end up getting 2x squared plus x minus 3. So this is my denominator multiplied out. This has an exponent of 1. This has an exponent of 2. So basically I only had to multiply my first two factors, the first two terms in my factors, and I would get a squared term. So I can see this is bottom heavy, and if you remember things where the exponents are bottom heavy, that means that my horizontal asymptote is where y equals 0. So y equals 0 is my x-axis. Okay, so I actually put this in the calculator. Let me go ahead, and that's the one we previously did. I'm going to turn that off. So notice I'm putting this in the calculator right here exactly how I see it. I'm not going to multiply it through or anything. I'm going to go ahead and graph it. And you can see that it takes on a certain form. So this one here, I'm going to be careful. It looks like it goes through something right here. So notice how this goes down. It's like a hairpin. And right here, this comes up, gets really close, but doesn't cross. And then same thing here. Okay, so that's a sketch of my function. So we still haven't talked about end behavior. So end behavior, if I say x is going to negative infinity, remember this is nothing more than the left side. So I'm going to look at my left side. My left side is over here. Okay, so that is my left side. Where's the function going? Well, it gets stuck where y is 0. Notice my horizontal asymptote and my end behavior are the same. So I'm going to say that my function is going to 0. Okay? So notice that these here are linked. There's a link here. They're connected. End behavior and horizontal asymptote are related. So then if I want to say right side, I'd say x goes to positive infinity. So remember this here is the same thing as right side. And my right side is over here. So where's the right side going? Well, the right side is also getting stuck where y is 0. So that means I'm going to write f at x goes to 0. And that's how I would state my end behavior for a rational function.